Okay, let's talk about implicit differentiation. So with implicit differentiation, we don't have to solve our equation for y. Okay, I don't know if you know this, but y equals square root of 25 minus x squared is the same equation as x squared plus y squared equals 25. So both of these are circle equations. Well, okay, this one's only a half circle, right? The top half of a circle centered at the origin with a radius of 5. Okay, that's what this graph is, right? Because it's only the positive square root, so we only have the top half of the graph. Okay, and that's not really important to implicit differentiation, so we don't really have to write this down. But our second one is a whole entire circle centered at the origin like that, okay? So if we were to, if you were to take the derivative of this, right, what main derivative rule would we be using? This would be the chain rule. The chain rule is the main one. Yes, we're taking the derivative of a square root, so hopefully you memorize the square root derivative, so you don't have to write this as something to the 1/2 power and do all that garbage. Wonderful derivatives. Okay, hopefully you have memorized this. So y prime, if y is your equation, then we're talking about y prime, is 1/2 times the square root of our function, right? That is the derivative of the square root. Okay, times, and here's the chain rule part, the derivative of your thing underneath your radical. So this is a negative 2x is the derivative of 25 minus x squared. Okay, so we could divide the 2 by the 2 and get a final simplified answer of x over square root 25 minus x squared. Right? And that would allow us to calculate the slope of the tangent line at any x value on your curve, okay, for that half circle. The negative of x divided by the square root of 25 minus x squared. Okay, so if you wanted to know what the slope was at any x value, you could plug it into that formula. Okay, which is good. It's good to know how to take a derivative if it is explicitly, right, solved for y. But sometimes solving for y is a really hard thing to do. So let's talk about how we do implicit differentiation, right? Sometimes called dy dx, the derivative of y with respect to x. Okay, so there's one thing to remember. Every time you take a derivative of y, we always have a bonus term. Okay, there's always a chain rule when we do a y derivative. Okay, so let's attack this one term at a time. What is the derivative of x squared? 2x. Okay, that's the derivative of x squared plus. Notice how I'm not writing dy dx or anything equals, right? You just go ahead and straight up start taking a derivative. Now, we're going to treat y squared just like we treated x squared. So the derivative of y squared is going to be 2y. But because of this special dy dx, every time we take a derivative of y, we have this extra term, y prime, right? Because this is your chain rule with our y derivative. You take the derivative of the equation and then you multiply it by y prime, also known as dy dx. So if you want to write dy dx right there, that is wonderful. If you want to write y prime and save yourself some fractions and some sloppiness, that is also wonderful. Okay, me, myself, and I prefer the y prime, only because it's cleaner. It looks nicer on the page. Equals, what's the derivative of a constant? 0. So anytime we have a constant and we're taking its derivative, the derivative is 0. Okay, so now our last job is to solve this equation for y prime. okay, or dy dx if that's the way that you wrote it. So we want to get y prime by itself, right? Isolate is the physics term. So our first step would be to subtract, right? We're going to subtract 2x over here. And our second term would be to divide by 2y, right? That would be our last step if we were going to do this algebraically. And we were actually writing down our steps one at a time. So the first thing we do is we subtract 2x, so that's the negative 2x over here. And then we divide by 2y, right? Because it's multiplied. So to undo multiplication, we divide. So one more simplification, we can divide both of these by 2, so we have the negative of x over y. Now if we knew a coordinate, right, if we knew the coordinate 5, 0 was on our graph, we could find the slope at that point. If we knew the point 3, 4 was on our graph, we could find the derivative at that point. You have to have both the x and the y in order to find an explicitly derived slope. Right? To find an implicitly derived slope, you only need the x term. No, switch those. Implicit, you need them both, right? Because this is implicit. Explicit, you only need x. Okay, so sometimes it's a little less helpful to be doing it implicitly because you have to know more information. Okay, so there's our first foray into implicit differentiation. Okay, we're going to fill out this nice chart. Our next part is wanting us to find the slope, right? dy dx, this is still the derivative. It still means slope, like all derivatives do. It wants us to find the slope of the tangent line at these 4 points. Okay? So in order to do that, we are going to create an equation to help us find the slope of the tangent line, aka the derivative. So this equation, right, this one would be kind of hard to solve for y, right? It would not be a very beautiful looking equation and would actually be really awful to try and do. So we're not going to want to solve this for y. We're going to just differentiate implicitly. Okay, implicit differentiation. So just to make it easier for us, let's multiply this all out, right? X minus 3 squared. And let's multiply y plus 2 squared all out so that we have a whole bunch of terms that we can look at individually. So there we have multiplied it. Now let's take the derivative implicitly. So let's look at every single term. What's the derivative of x squared? 2x. Minus, what's the derivative of 6x? 6. What's the derivative of a constant? 0. So that one's not included anymore. Plus, what's the derivative of y squared? 2y, and we always have to multiply it by y prime. Okay, this is our chain rule for y, right? It's dy dx. And since there's no x in that term, the derivative is 2y and then y prime. Plus, what's the derivative of 4y? 4 times y prime. Anytime there's a y in your derivative, we have a y prime. And the derivative of 4 is 0, and the derivative of 25 is 0. Okay, so this is, you just have to remember, anytime you're taking a derivative with y, you always have a y prime. Okay, every time. So yes, the derivative of 4y is 4, but then we have to multiply it by y prime, right? That's our chain rule for all of y. All of y. Okay, so 2y times y prime plus 4y prime. So now it's a matter of solving for y prime. So let's get rid of all of these terms. We're going to move all of these terms over to the right side, right? We're going to subtract them to the other side of our equation. Okay, so that's going to be equal to a negative 2x and a plus 6. Okay, right? We're going to subtract the 2x, we're going to add the 6. And now, what do these two terms have in common? They both have a y prime. Okay, so we're always going to be able to factor out a y prime from every term that had a y in it. Okay, this is part of the algebra that we're going to need to get familiar with. So this is 2y plus 4 times y prime. Okay, both of these terms have a y prime in them, so we pull them out as a single y prime. Okay, so we have a 2y plus the 4, that's left over. So if I wanted to solve this for y prime, what would be my next algebraic step? Divide the red stuff by the purple stuff. And this is your derivative. Implicit differentiation. Okay, we still get a nice equation, but we have an x and a y. We need to know 2 points, or rather 1 coordinate, right, 2 parts, in order to find the slope of the tangent line at any point that we're given. Okay, so yes, we're going to practice some more. Don't worry if it's still fuzzy in your amazing head. So let's check it out. What is the slope at the point 0, 2? So we're looking for the slope of the tangent line right there. Okay, so we have an x part and we have a y part, and we have an equation that has x and y. Okay, so the slope, or dy dx, right, we could write that if you want to, or you could write y prime equals -2 times 0 plus 6 divided by 2 times 2 plus 4. You plug the x coordinate in for x, and you plug the y coordinate in for y. And now it's just a matter of simplifying. Negative, that's a 0, so 6 over 4 plus 4 is 8. So our slope is positive 3/4. Okay, so we replace x with the x coordinate, replace y with the y coordinate, and we do the math, right? We simplify it down. So let's come over here to our graph, and from here, let's make a 3/4 slope. So up 3, right 4. Down 3, left 4. If I connect these lines, does this look like it's the tangent to my graph at the point 0, 2? Yeah, it pretty does, right? It looks pretty good. That would be the tangent line. I would agree that that would be the slope of the tangent line. Okay, so we could do that same math for all of these coordinates, and we can get the slope of the tangent line at any coordinates on your circle. Okay, so let's do some more practice with differentiation. Okay, so what do you notice about 2xy? What operation is going on between the 2, the x, and the y? This is multiplication, also known as a product. So whenever we have 2 letters that are squished together, we're going to use the product rule in order to find its derivative. Okay? Anytime, every time you have 2 letters that are squished together, we're going to use the product rule just for those 2 parts. Okay, so remember the product rule is f prime g plus fg prime. And you can, of course, switch those 2 back and forth, fg prime plus f prime g, since addition is commutative. Okay, so we're going to pull the 2 out and just deal with the x times y. Okay, so put the 2 on the outside, and now we're going to use the product rule with x times y. Okay, so we're going to call x the f term and y the g term. So what's the derivative of x? 1, and then we're leaving y alone, so that's just 1y plus We're going to leave f alone, so that's going to be x times, what's the derivative of y? Y prime, right? 1, just like it was for x. So let's go back here. The derivative of y is 1, just like the derivative of x was 1. But anytime we're taking the derivative of y, we need to have a y prime. Equals, let's move over. Okay, we're going to do derivative of 3y squared as if it were an x, right? So we multiply the power times 3. 2 times 3 is 6y, so that's the derivative of 3y squared, but we also have to multiply it by y prime. Okay, every time we take the derivative with a y term, we always have to have a y prime as part of the derivative. And what's the derivative of 2x? Just the number 2. Okay, beautiful, right? That's the calculus. Remembering to do a y prime every time we take the derivative of y, or a y term. So now comes the algebra, getting our y's together. Okay, we got to get y prime together. So let's start the algebra. Should we multiply everything by 2 over here? Or should we divide everything by 2? I think you would multiply, so let's multiply. I think that's what you would do. So this would be a 2y plus 2x y prime equals 6y y prime plus 2. So we're going to move our y primes. We're going to take this 6y y prime, and we're going to subtract it over to the left side. Okay, and likewise, I'm going to take my 2y, and I'm also going to subtract it to the other side. Okay, so we want to get the y prime things on the same side, and everything else on the opposite side. Okay, this is the implicit algebra. So we have 2 minus 2y. So now we factor out the y prime from both of our terms on the left side. So we have 2x minus 6y in parentheses, right? Because that's what we have when we factor things, is we change it into multiplication. So this is 2x minus 6y, both of those terms, times y prime. And our last step is to divide by the term in front of y prime. So 2x minus 6y. Now the only thing we could do to simplify, since they are all divisible by 2, is we can divide them all by 2, everything divisible by 2, and get a 1 minus y over x minus 3y. Okay, so the last thing we could do would be to divide and simplify your numbers. But of course, if it's an FRQ, that is not even necessary. You could leave it as 2 minus 2y over 2x minus 6y. Here we have another example. You don't want to solve this for y, right? We have e to the y. All right. And then we have minus y squared. So term by term, let's take the derivative. So the derivative of 2x is just 2, plus the derivative of e to the y, or derivative of e to the x, is just itself, right, the same thing, times the derivative of your exponent, which is y prime. Right, the derivative of y is y prime. Equals, what's the derivative of x squared? 2x. Minus, let's derive y squared. So first of all, we do it like normal. The derivative of y squared is 2y, like it was an x, but then you multiply it by y prime. Because anytime we take the derivative with y, it always has a y prime attached. because it doesn't have an x term to derive it. Okay, so now we do the algebra. Let's get our y primes on the same side and our non-y primes on the opposite side. So I'm going to bring this purple term over to the left, and I'm going to add it. Since it's a negative, I'm going to add it over here. And I'm going to take my red positive 2, and I'm going to subtract that over here. Okay, so I have my blue e to the y times y prime, and now plus 2y y prime equals 2x minus 2. Okay, so you get the y primes together on the same side, and you get everything else together on the other side. So just be careful of your sign, your pluses and your minuses. Right? We got to make sure to add the opposite or subtract if it's a positive to get over there. Now we need to factor. We factor out y prime. So we have e to the y plus 2y, right? Those are our terms there. And if we do enough of these, right, you're going to know our next step is to divide. So our last step is 2x minus 2 over e to the y minus 2y. Right? Just imagine that I divided that over to the other side, and this is no longer there. So there is your implicit differentiation. Every time we take the derivative with a y, you need to have a y prime or a dy dx if that's what your teacher wants you to write. All right, have a swell implicit day.